9.5 meters below space and time. This crash did it. So how much interest? Well, I'm going to take this vector equation.
Welcome back to Physics Teacher for another episode in our video game physics series. In a previous episode, I was issued a challenge in the comics to figure out the diameter of the ball in Rocket League. So, challenge accepted. And I started to make this video. And as I started to play the game, I realized it doesn't give you any information at all. There's no speedometer. The cars aren't any brand name cars, so I can't look up their actual sizes. I don't even know if the soccer field there is an actual soccer field size. There's nothing I could get until I saw this. Did you see that? It told you some information. It told you the speed at which the ball crossed the goal. And I'm going to use that one piece of information and the projectile motion it undergoes from the center of the field to the goal to figure out the length of the field, the diameter of the ball, and I also want to figure out how fast the cars are actually moving. But to do that, I'm going to need a little bit more information. So we went into the training grounds and got these two videos. Alright, so we have all the videos we need. Let's start our analysis. Alright, so here to do all the analysis that I need in this video, the only data I need to collect is time data. I need to know what the time it takes for that projectile motion from the center field to the goal. I need to know the time it takes for the ball to actually cross that goal line. And I need to do it in both regular speed and in the slow motion that the video game presents. And finally, I need to know the time it takes for the car to cross the field under normal speed and under boosters. So now that we have all of our data points, let's analyze this. The first thing we're going to do is find out the diameter of that ball. Doing that provides two challenges. The first, it shows the ball crossing the finish line in slow motion. So the time that I take from that video is not the actual time required for the ball to cross the finish line. Challenge number two is it tells you the velocity of the ball as it crosses the finish line. But I want to know its horizontal velocity as it crosses the finish line. Alright, so one challenge at a time. Now first, the time. So the time issue I solved in this way. So we see that parabolic motion of the ball after it's hit. Now I hit it very nicely so that when it's launched, and then when it hits the goal at about the same height that it was launched at. So that was on purpose, required many takes. Alright, and after you score a goal, it repeats that entire parabolic motion. So what I did here is I figured out the time that that parabolic motion took to occur during normal time and how long it took to occur during slow motion. So I can see how much it was actually slowed down by. So that's over here. So these first 2 points are the difference in time from when I hit it to when it reached the goal under normal time. So let's look at that. We'll find the difference between those times. So we have 8.08 seconds minus 5.64 seconds. And we get 2.44 seconds. So that's in regular times. So let me call that R. Now in slow motion, That's what I recorded afterwards. So that is here and here. So from 15.84 seconds to 18.6 seconds in the recorded video. So let's find the difference between those times. So 18.6 seconds minus 15.84 seconds. And we get 2.76 seconds. So it doesn't slow down time by much, but we'll still take it into consideration. So if I find the ratio of these, so 2.76, these are seconds, divided by 2.44, we get 1.13. So it was slowed down by 1.13 times. All right, so our first challenge has been solved. The next challenge is to figure out its horizontal velocity. So when it crosses the field line, it says its velocity is 83 kilometers per hour. If you divide that by 3.6, we get 23.1 meters per second. But that's its final velocity in that motion, in that parabolic motion, which is like this, so 23.1 meters per second. But that can be broken up into a downwards vertical component and a sideways horizontal component. Neither of which I know. But I do know these are right angles. So this goes back to when I told you that the angle that it got hit at and the perfect speed it got hit at caused it to cross the goal line just as it reached back down to the field. So it left at the same height as it took off from, like this. That means our displacement in y is 0. We know that acceleration, and I'm assuming acceleration is going to be that of Earth, so I am assuming this game is being played on Earth, and I'm going to make down positive. So it's 9.81 meters per second squared. And lastly, I know the time. We calculated that. The time it takes for that entire motion is 2.44 seconds. All right. With this, I can calculate this final velocity in y. So let's do that. So we have delta y equals final velocity in y times time minus 1/2 a delta t squared. So this term is 0. And then we can divide every term by a time factor, since we know it does not equal 0. And rearranging, we get final velocity in y equals 1/2 a delta t. If we sub in what we know, 1/2 9.81 times the time, we get our final velocity in y to be 12.0 meters per second. So we know this is 12.0 meters per second. So now, using Pythagorean theorem, we can find out what our horizontal velocity is. So our horizontal velocity will be the square root of 23.1 squared minus 12 squared. And we get a horizontal velocity of 19.7 meters per second. All right, so now that we know that it's moving horizontally at 19.7 meters per second, we can go ahead and figure out the size or the diameter of that ball. And right over here in the video, I calculated each frame, the time at each frame for when the ball first hit that line that it needed to cross to score to when it completely passed that line. And so the distance that ball would have then traveled will be the diameter of itself. So we can find the diameter of that ball by simply finding the distance it travels. And that's just distance equals velocity times time. All right, so velocity is what we calculated. It's 19.7 meters per second. Now the time, which is the difference here from 18.60 and 18.48. So let's write this at this side here. It's the difference between those, 18.6 seconds minus 18.48 seconds, which gives us 0.12 seconds. But that is in slow motion. So this is where we're going to use that slow down factor to figure out the actual time it took for the ball to traverse that goal. So I'm going to divide by that factor that we calculated by, that it's slowed down by, 1.13 times. When I do that, the actual time it took the ball to travel that goal is 0.106 seconds. So we can multiply that by 0.106 seconds, and we get the diameter of the ball to be 2.10 meters. It's a little smaller than I thought it would be, but still satisfying. We know the diameter of the ball. Now I was going to stop here, because that's the challenge, to find the diameter of the ball in Rocket League, but I wanted to take this a step further. I wanted to know, is that field really about the size of a soccer field? And why doesn't it display a speedometer in this game? How fast are those cars actually traveling? So I took it a step further, and this wasn't a difficult step. We calculated the time it took for the ball, right here, to traverse half the field during that projectile motion. And I know the horizontal velocity. And looking at that projectile motion, it is a nice parabolic shape. So that pretty much tells me I can ignore air resistance, which means I can figure out easily half the field by taking its horizontal velocity and multiplying by the time it took for that ball to traverse half the field under that horizontal velocity. So let's do that. So half the field is going to be that horizontal velocity of 19.7 meters per second times by the time it took to travel, 2.44 seconds. And that's under regular time, not slow motion. So we don't need to adjust anything there. And we get 48.1 meters. So the full field would be double that at 96.2 meters. Okay, it's actually a little bit smaller than a soccer field, because most soccer fields average between 105 and 110 meters long. So 96.2, it's actually smaller. It was a little bit shocking. It's smaller than a soccer field, but they drive cars all over it. I would have thought it would have needed to be bigger. All right, let's analyze the speed. And that's where these next two videos came into play. So if we go over to the next part in our video analysis, I took the time that we started at one end of the field, where we crossed the center, and where we finished. So what I'm going to do is I'm just going to take the center to the finish line, making the assumption that by the time we've reached the center, we've reached our maximum speed, and we're going to be moving at constant velocity after that. And I did that here, moving without any boosters, and here, moving with full boosters the whole way, as you saw in the video. So let's calculate what those speeds would be then. So the first one, without boosters. So the speed is simply the distance you traveled, which is half the soccer field, 48.1 meters, divided by the time it took, which was the difference between 26.27 and 22.60. And we get a speed of 13.1 meters per second. That's about 47 kilometers per hour. I would have thought it would have been faster. I mean, it is an exciting game. I quite enjoy it. Okay. Well, what about the other speed when we're on boosters? Well, same thing. Go to the next page. Our velocity is going to be the distance that we traveled, which was half the soccer field, so 48.1 meters. Divided by, now here's the difference in time here, from the midpoint to the other goal, so 27.73 seconds, minus 25.5. And when we do that, we get 21.6 meters per second. Huh. That's about 78 kilometers per hour. My 8-year-old van can do better than that. I can probably drive circles around these cars in my 8-year-old van. Well, that would be a good reason why you probably wouldn't want to show the speedometer in this game. It's not very exciting to see yourself driving around the field at 40 to 80 kilometers per hour. Usually when you're playing fast games like this, you want to see something faster. So, probably a good idea not to show people that. I hope you enjoyed that video, and stay tuned for the next one.